So hello guys, welcome to another video of 100 days of 100 coding questions challenge. Today is our 61st day of this challenge and we had completed 60 problem of the days on Leetcode in the last 60 days. Okay, so let's begin with today's problem. That is problem number 840, that is magic squares in grid. It is a medium level question and the topics that are included in these questions are array, hash table, maths and matrix. Okay, so it is a medium level question based on the matrix traversal or simulation. So let's see what is this saying. So at first we have given the definition of a magic square. So what is a magic square? A magic square is a 3 by 3 matrix or a square in the given grid, which have every field filled with distinct elements from 1 to 9. Okay, so in that magic square, there are 3 by 3 elements, that is 9 elements, and all the elements are distinct, and range of that element is 1 to 9. Okay, and the sum of rows, columns, and its both diagonals are equal. Okay, suppose if the sum of the row of that given matrix is 3, or suppose it is 5, so the sum of every row, every column, and both of the diagonal is 5. Okay, so if it is fulfilling this conditions, then we will call it a magic square, and we have to return number of magic squares, that how many number of magic squares are present in the grid that is given to us. Okay, so the grid will be given to us, and we have to return the number of magic squares that are present in that grid. Okay, so it is a very easy question. We just have to calculate the sum of every row, every column, and every diagonal of a 3 by 3 matrix, and we have to do this thing for every 3 by 3 matrix in the given grid. Okay, so at first, suppose for example, I have given this grid. Okay, so I had written this here. If I have this grid, so for the first 3 by 3 matrix, that is 438, I will write it down. It is 438 and 951 and 276, that is 276. So for this 3 by 3 matrix, or I have selected this matrix on this given grid. So for this grid, I will calculate every element or every rows sums or column sums or diagonal sums. Okay, so for first row, the sum will be 4, 8, and 3, that is okay, so I had written all the columns and row sum of this grid. So first row will give me the sum of 15, second row also give me the sum of 15, and the third row will also give me the sum of 15. Simultaneously, we have column sum. So first column will give me the sum of 1, second column will give me the sum of 15. So third column will give me the sum of 15. The first diagonal will give me the sum of 15, and the second diagonal also had given me the sum of 15. So every row, every column, and every diagonal have the sum equal to 15. So they all are equal in some calculation. So it is a magic square. Okay, so the count will be at first it will be 0, and after I find the magic square, I will increment it to 1. Okay, so now for second square, that is 384 519 and 762. 762. For this, I will calculate the sum that will be equal to. So for this grid, I have the row sum. First row sum will be 15. Second row sum will be 15, and the third row the sum will also be 15. Column 1 will give me the sum of 15. 2 will give me the sum of 15, and 3 will give me the sum of 15. But the diagonal 1, that is 312, will give me the sum of 6. Okay, and the diagonal 2, that is 417, will give me the sum of 12. So row sum and column sum are equal. Okay, but the diagonal sums are not equal, so it is not a magic square. Okay, and I have completed the traversing of all the squares, all the 3 by 3 matrices in the given grid. So it means I completed all the 3 by 3 matrices, and I have find only one magic square. So I will return this count, that is 1. So let's see this in the code. So at first I make a count, that is 0, an integer, that is 0, and the number of rows, that is grid dot size, and the number of columns, that is grid first row of grid dot size. Okay, so grid of 0 dot size. So it will give me the number of columns, it will give me the number of rows, and this variable will store the number of magic squares that I had uh, find out from the grid. So, okay, so I will mark the matrix. Okay, first I will take the 3 by 3 matrix, or select the 3 by 3 matrix. How will I select the 3 by 3 matrix? So for that I will traverse in the grid. Okay, so for which I will traverse in the rows, and for j with j I will traverse in the columns. Okay, so the last 3 by 3 matrix is from where to where. The last 3 by 3 matrix will be my last minus third index, or from last minus third index to last index. Okay, so for last 3 by 3 matrix I have to subtract last index minus first index, so it will give me the starting point of the last matrix, and simultaneously or for the columns, or it will be the same. Okay, so for the starting point I will get it with 0, and the starting point of the rows and columns, it both starts with 0. Okay, and for the ending point will be the starting, and the ending point of these loops will be the starting point of last 3 by 3 matrix. Okay, so for example, if I have this matrix, so the last and the ending point will be my 7. Okay, 7 will be my ending point of both the loops, because from 7 I will get the 3 by 3 matrix, that is the last 3 by 3 matrix. Okay, so for that I will use last index minus first index. So I have written I is equal to 0, and I is less than equal to rho minus 3. Okay, so last minus third index. Okay, and I plus plus, and also for j is equal to 0, j is less than equal to columns minus 3. Okay, so basically it will be from last minus third index from the bottomwards. Okay, and j plus plus. Check for the magic square. Check for the magic square. For that checking, I have written a function that is valid, and I am passing I, j, and grid. Okay, so grid is the whole matrix that is given to me. I is the starting point of that matrix for the 3 by 3 matrix that I had find out, and j will be the starting point of that column of that 3 by 3 matrix that I have selected out. Okay, so if it returns me true, if it will return me true, I will increment the count. Okay, so it will be my bool function. Okay, so I had written this bool function over here, and it is my private function. So is valid. It takes the three arguments, that is I, j, and that matrix grid. Okay, so I will be my starting point of row, j will be my starting point of column, and grid is my given matrix. Okay, at first I will count the frequency of every element, that is 9. Okay, so for every element the frequency should be only 1. Okay, because I have 3 by 3 matrix, and every element is from range 1 to 9, and all the elements should be distinct. So it means I have frequency of 1 for every element, that is 1 to 9. Okay, so for that thing I had checked all the frequencies of all the elements of that 3 by 3 matrix, and also I had checked for the range. Okay, so if the range is between 1 to 9, it I can consider it as my magic matrix. Okay, so if the range will exclude or include or if the range will exclude my given range, that is 1 to 9, it means it will not be my magic matrix. Okay, or magic square. So I had checked that if the number is greater than 1 and less than 9, okay, and should also be greater than 0, so it must be the positive integer, and it should be in the range of 1 to 9, and if it is not following this, I will straightly return false, that this 3 by 3 matrix will not be my magic matrix. Okay, after counting all the frequencies and got the frequency as 1 for all the elements, I will find the sum of first row. Okay, I will find the sum of first row and check if it is equal to the second, third, fourth, second, third row, and first, second, third column, and two diagonals. Okay, so I will calculate the sum as the reference sum, that every row sum should be equal to this sum, and every column sum should be equal to this sum, and every diagonal sum should be equal to this sum. Okay, so for that I had written the logic, that is x is equal to 0 till the x is less than 3. X should be less than 3, that is the size of the matrix, that is 3 by 3. So for rows I had incremented the value of I. Okay, for value of I for rows, so if it is 0, then 0 comma j, 0 comma j, and 0 comma 0 comma j plus 1, 0 comma j plus 2. So as you see, the columns are incrementing simultaneously, and this sum should be equal to this. If it is equal, then I can consider this matrix as my magic matrix. Okay, I will not consider this matrix until I check all the constraints or all the conditions. But if this is true, it will be my magic matrix after I had calculated all the things. Okay, and if it is not following this condition, it means it is not my magic matrix. So I will straightly return false. I will not check other conditions, because this condition is not in my range. Okay, so for rows I had calculated this, same for columns I had calculated this, and take y as the element, and I will increment y, this time I will increment y just because I had to traverse in columns. Okay, and for diagonals I had straightly calculated that for every increment in row I have to increment in columns. Okay, so for ij, for I plus 1 j plus 1, and for I plus 2 j plus 2. Okay, same as the second diagonal, I plus 2 plus I plus 2 j, I plus 1 j plus 1, I j plus 2. Okay, so it will be my first diagonal, it will be my second diagonal. And if in any place, at any place, if the given sum is not equal to the calculated sum, I will return false. And if all these things executed and no false return, so it means it is true, and I will return true. And if I have returned true, I will increment my count, and after that I will just return my count as I have traversed all the 3 by 3 matrices in the given grid. Okay, so let's run this code. Hopefully it will run. Yes, it is running fine, and let's submit it and see if it is passing all the test cases or not. Yes, it is passing all the test cases and 64% faster than other C++ users. So by this, I have completed the code of the day of today and 61st day of this challenge, that is 100 days of 100 coding questions challenge. And if you have any problem in this code or any code in our challenge, you can get the repository links in my description. You can go there and check the codes. I had uploaded all the codes of our challenge. That it will be over here, and for today's code I will be leaving the link in the description, solution link in the description, so you can go there and tell your code with my code. So thank you for today.